Hello, today we are going to discuss about spanning tree protocol, that the protocol which is used by switch to send the packet in a network. So in this we will learn about what is a spanning tree protocol, then how switching loops occur in a network, then the problem caused by the switching loops and the various STP terms and the switch port status. So let's first discuss about what is the spanning tree protocol. So the spanning tree protocol or STP is a network protocol that builds a logical loop-free topology or a logical loop-free network for any switched Ethernet local area network. So its basic function is to prevent the switching loop and the broadcast radiation or the broadcast roam in the network. And the spanning tree also allow a network design to provide backup links, means if active links fail or any active link fails in the network, then it provides the backup link to that network. So STP was invented by Radia Perlman while working for Digital Equipment Corporation, and the standard used by STP is IEEE 802.1d. So this is the standard of STP. So this here we know that the STP's main function was to prevent the switching loop and the broadcast radiation in the network. Next is switching loop occur in the computer network. How switching loops occur in a computer network? So let's discuss about this. That a switching loop occur in a computer network when there is a more than one layer 2 path or more than one path to reach the destination or reach to the endpoint. So switching loops will occur. This interconnection of interconnected devices network is designed to reduce the redundancy, means to provide the another path if one links fail, to provide the another path to route the packet in the network. But this interconnected result into the formation of loops in the network. So the loop creates broadcast roam as packets are forwarded by switch to every port. This switch will repeatedly rebroadcast the broadcast message, resulting into the flooding of network. Because if any packets sent in the loop network, then it will remain in the loop forever. It will not discard in the network. So this causes the flooding of the network. And as layer 2 devices, which doesn't support TTL, that is time to live value. The header of the packet doesn't include this value, that is time to live value, which define the maximum hop or the intermediate devices travel by the packet. So as it is not defined in this switch packet, so if a frame is sent into a loop topology, it will loop forever in the network. So the solution is to allow the formation of physical loops but create a loop-free logical topology and network using spanning tree protocol on the network switches. As shown in the example, this is an example where the three switches are interconnected and they are interconnected to reduce the redundancy. So switch A, B and C are interconnected to each other, and they are interconnected to reduce the risk of packet drop due to failure of the link. So let's suppose switch A send broadcast message in a network. So this broadcast message is received by both the port, like switch B and switch C. So as it is a broadcast message, then switch B and switch C rebroadcast the message in the network. So then the message received on switch B is forwarded to switch A and switch C. Simultaneously, the message received by switch C is rebroadcasted to the switch A and switch B. So now see here that switch A receives the two copies of its own message, while another two copies will produce loop in the network. So in this way, each message entering the loop will remain in the loop forever. This led to the formation of switching loop and the broadcast roam in the network, and this will destroy the network performance. So the performance of the network will be failed. The next is the problem caused by the switching loop. So the switching loop causes three problems, that is broadcast roam, second is MAC address flapping, and third is the multiple frame transmission. So first is broadcast roam. So as broadcast roam is a situation in where the packet are broadcasted over switching loop and they will remain in the network forever and they form the endless loop. So first is broadcast roam. The next is MAC address flapping, that's media access address flapping. So as we have seen in the example before, that switch A receives the 2 copy of its own message from the switch B and switch C. So it receives same message from the 2 different MAC addresses. So here the MAC address flapping will occur. So a loop can make a switch to receive the same broadcast message on 2 different ports, which cause misleading entries in a switch MAC database. This process is known as MAC address flapping. And next is multiple frame transmission. That is, switch will receive a copy of frame from 2 different ports, like as switch A receives the 2 copy of its own message. The next is spanning tree protocol, the terms related to the spanning tree protocol. So before discussing about how spanning tree protocol works, let's discuss about its few terms. So spanning tree protocol is used to prevent the network from the switching loops. So here are the few terms, that is root switch. So root switch is a switch with a best bridge ID or the switch ID. Note that STP protocol is used by switch as well as by the bridges. So somewhere I have used switch and somewhere I have used the bridge, so they are the same. So root switch is a switch with a best bridge ID or a switch ID, and all decision in the network is taken by the root switch. Next is bridge ID or a switch ID, through which we elect the root switch. So it is formed with the combination of or with the addition of switch priority and the switch MAC addresses. Or by adding switch priority and switch MAC addresses, we get the bridge ID or the switch ID. So the switch with the lowest ID will become the root bridge in the network. The next is root port. So it is the nearest port from the root switch and always remain in the forwarding state. Whereas designated port is one that has been determined as having the best lowest cost or lowest port ID. So designated port will also remain in a forwarding state. Next is alternate port. Alternate port or non-designated port or blocking port. So it acts as the backup port and it cannot forward any data to the network segment it is connected to. The next is BPDU packet, that is bridge protocol data unit. So these are the packets which are used by the switch in the network to exchange the information about the selection of root bridge or the root switch, root port and the designated port, etc. The next is the switch port status. So these are the port status, like disable port. It only learns the MAC addresses and calculate the STP. So it's only learn MAC addresses, can't receive and send the BPDU packet. Next is listening port. So it receives and sends BPDU packet only. So it doesn't calculate the STP. Next is blocking port. It receive and deal with the BPDU packet but not send BPDU packet. So here it doesn't learn any MAC addresses or calculate STP. Next is learning port. It learns MAC address, calculate STP, receive and send BPDU packet. Whereas forwarding port, it forward the data, learn MAC addresses, calculate STP, receive and send the BPDU packet. So learn about these terms, and in next lecture we will discuss about how STP works. So this is all about spanning tree protocol. Thank you.